So let's go ahead. Let's get done with this. So we're basically what I was missing. The piece that I was missing is to create another TOEFL. It's going to be the TOF swap, which is basically the one that I'm going to have to use at the end of my multi-control knot. That is this piece of the whole puzzle. This one here. So that's what I want to. It's a normal TOEFL, but it has a built-in swap that's going to be used. That's just going to enable us to build that in this type of architectures or mappings. And it has that piece at the end here, which basically it's basically a phase correction, which is what you don't have. Which is what you don't have in this implementation, but you don't care. Like as your target, our target is to build a multi-control knot, and so the phase correction can be corrected at the last step. And because we're going to concatenate many of those to save up on control knots, we're going to use this implementation. So we don't have so many control knots because this one has 2 extra, right? So we've got 2 extra ones in here. So we're gonna do this, okay? So let's see, how do we do this quickly? So we're gonna basically create a insert cell in here below, and we're gonna do a no. What is this? Replace no. So we're gonna do a TOF S for TOEFL with a swap, quantum circuit, and it's gonna also be 3, and we're gonna do a TOF S. So we start with a. Now I should be recording my desktop, so that should work now. If I basically put this side by side, should be able to just quickly do a Hotmart on the Qubit 2, a Control X between the qubits 0 and 2. Then we've got a TOF as a TDG, like a T-dagger on 2. TOF S, probably copy that. TOF S, a Control X between 1 and 2. Then we've got a T-gate and 2. And we got a CX gate 0 and 2. Now we've got again the T-dagger on 2, and it's the same approach that we described in the. So now I'm going to do a swap. It's the same approach that we discussed in, or that you can see in the other RTOFs, right? Those partial approximation. You're approximating step by step, but in this case, you're having this kind of phase correction here. So because if you remember that had that little, like, you ended up with a state, you ended up with like a phase of 90 degrees. I think at the end. This phase is gonna. You don't want to have that because you don't want to have that in your amplitude amplification. Within your amplitude amplification, I kind of realized I was thinking whether this really bothers or not, but it does bother because that's all what the amplitude amplification does is play with your amplitudes. So it kind of creates the right type of interference. It turns destructive interference into constructive interference for those elements that are flagged a certain way. And so if and particularly that multi-control X is the essential part of the whole amplitude amplification. So if you, because that's kind of basically the piece that makes that that whole shift. You can take a look at on my other Grover videos where I explain that. Like I have a short version, like a 10 minutes version of Grover's interpretation, where you can see that clearly. That's what amplitude amplification does, regardless of all the geometrical interpretations and whatnot. What it does is, I'll explain that quickly again. Is it takes, so if you're having a superposition of your different values, right, and so you're phasing, for example, let's say that you're gonna you're going to phase that element here by 180 degrees. So you could think of this as, the operation of you're kind of adding, you're adding more, more of those elements in your bucket in here. And then what the amplitude amplification does is, because so that basically, if you think about the final state that you see here, is it's plus 10, minus 10, minus 10. So it's like a minus 10. That's kind of the desired effect. But if what the amplitude amplification does is it negates that whole thing here, which is your superposition that is seated with like the zero state, right? And now that minus and those minuses, they don't cancel anymore. They just amplify. So they amplify by 3x, right? And so that's kind of the effect. So so the point here is if your multi-control X is not, if your multi-control X is not set up the proper way, that won't work. And I think that's the key point here. So let's go ahead and let's see. Can I just delete everything? I just wanted to delete everything. I have to do this by hand. Whatever. Okay, so let's go back to this. So control X between 2 and 1, and control X between 1 and 2, and that should be a swap. And then we're basically doing a T-gate on qubits 0 and 1. We're doing a control knot between 2 and 0. We are now doing a T-dagger on 0, a Hadamard 1, and we can take a look at how this correction really works afterwards. I just want to make sure that this kind of gives me the results that I expect, because if not, I'm going to be quite lost. But this should be this should really work. And now finally, we're going to do a control X between 2 and 0. And so now we got these done. So one of my quantum circuit is not defined. Really gotta go through the whole thing again. Sorry. So what are these things doing here? These drawings, whatever. Okay, so now this works. I'm gonna insert a cell below, and I'm gonna do this draw output equals MPL. So we should have that little thing in here. I missed one thing though. I see that one. I thought that would work. Key 0, key 1. Oh no, it did work. It's just here. Okay. Yeah. Okay. Yeah. Perfect. And so we go ahead with this. And we've got all our bits and pieces in here. Now, this is not going to be an art of M-gate. Oh yeah, I gotta make it an instruction. So I gotta make it a S-gate equals these to instruction, right? So now I need to use these instead of these in theory. And I need to add a swap between, let me think, what are the qubits that I need to swap in here? 2 and 3. 2 and 3. No. I need to swap. So I need to swap. So I start with 0, 1, and 2 is the ancilla qubit, and then I do 2, no 4, sorry, and then I do 4, 2, and 3. So 2 and 3 I gotta swap. Yeah. So I gotta then add a swap between 2 and 3. Let's see. That seems to be it. That seems to be it. Oh, I had to cough. So now let's see. Let's see. Let's see where does this whole thing take us. Let's hope that it works. Okay. It's not perfect, but it's not the worst. Huh. The thing is, it's not the same. These are not the same results like I would expect in the. It's not the same results that I could see here in the paper, right? Um, Let me see. Well, now maybe I can try on computing, and maybe that uh, helps by just adding that part in here. So now, sorry, not this part in here. This is what you want to do. If uncomputing is needed at all. Uh, hmm. And you need those harmonics in there, right? Yeah, because you're doing a control. So you're no. Now that messes it up completely. But yeah, that's the worst thing. Why on earth would that be so? Yeah, minus 20 represented Stuff like it's other than anything close to the dash box can be replaced with a relative phase gate. Either by the phase gates can be reduced. Mm. So RTOF, for RTOF and for RTOF will swap, and then you're undoing, and then return the target states and procedure. Hmm. Mm. Yeah. It's not giving me the right. So at that point, I don't know where to look at. I mean, it definitely looks like with CC, like definitely works like with like with CCX gates. It exactly works like expected, but not like these. Now in the paper, so let's go back to one screen. So in the paper, here at the end of the paper, there's the actual circuit, right? So let's compare one by one. I see the first weird thing that I see is that this is this is the beginning of the diffusion operator, but that might be just equivalent. I mean, if I take a look at, sorry, the mic is going crazy, so I had to pause for a second. Okay, so that might be equivalent. I mean, I haven't seen that before in terms of Grover's diffusion operator, because that's usually the way Hadamard's and knots. Um, Hmm. Let me see. Let me quickly see if that, for any reason, has any impact on this. So we're using Zs and Hanomards, and then Hanomards and Zs. So I would just say these Zs and Hanomards, and then Hanomards and Zs. Have any that even restart the kernel. Can I just restart and run all cells? Is it that I'm messing up? Okay, they're being run. That's not. That's so. But even if I do that and I just uncomment, like, now wait a second. But then when they do it this way, they are not here using any extra Hanomards. So then they would not need that extra Hanomard in here and that extra Hanomard in here. So they're doing. It's even more messed. That's if I replace that with if I replace that, okay, with simply a CCX 014. So if we do it this way, okay, so that's the ideal case, using the Z and the H in there. I'm not even getting, like, what, that can't be correct. Like, that can be correct. Okay, so this goes into the feedback document. I think that's definitely not, that's weird. Because I was getting better results. With H and X, and those shouldn't be equivalent. I mean, I don't think they're equivalent. Why would is that, like? I'm trying to think. Even instance of the blocks here, if you do the Z, let's say you're in plus state, and then with the Z you go to minus state, so you go to the 1 state, right? And if I say that it is indeed seems to be equivalent. If I am at the plus state and I do Harman gate, go to the 0 state. If I do X, I go to the 1 state. So so the 1. So let's. Where did I have a? So the blocks here. So the Z plus these, and then the Hadamard takes me kind of, okay, not with this path, but down here. Whereas the Hadamard would take me up here, and then the X would take me down there. But the results I'm getting are completely different. It's pretty funny. So let me go. Okay, so that's getting pretty nasty. I know. Hardmarts and X gates. Hardmarts and Hardmart gates. And I do need these Hardmarts because we're doing. So now this is the ideal case. And if I do these, it works, right? That's the point. That's my whole point. Yeah, that's exactly. That is indeed. So I'm gonna have to. I don't know. I'm lost in here. So I'm gonna have to. So that works. Then I must be doing something wrong with the. I thought it was the phase correction, but it's not. Because that definitely gives me the same results that I see in here for the simulator. RTOF IX and RTOF M, they give really similar results. Indeed, they're really similar. Uniform random output. What is this? Acknowledgements. Now, what is it about? So let's take a look at these. Okay, so I need to maybe open the paper twice in another tab. Put it side by side, and just go through these. I don't get it. What am I doing? What am I doing wrong in here? So. So they all have the same shape. So they start with these, right? And I'm doing the same, right? So I'm basically using, let's say I'm using that. So that's all the same. T dagger, T dagger. Okay, but wait a second. Okay, now that's going to be messy because here they've decomposed. Here you can see this granularly. And now I got the black boxes. Now I got these damn black boxes down here. I got the damn black boxes. RTOF M. RTOF M. Or just RTOF. Maybe. Okay, maybe that. So RTOF. RTOF gate. That's the one with the T's. That's the IX and RTOF S gate. That would still mean a swap. So that's the, and now, what am I doing wrong? It's TOF gate, sorry. TOF S gate. Sorry, I should remove these. Remove these, exactly. And so, yeah. And so now I've got the for the top S gate, which is this one here. I think I missed something in here. I think there's a mistake in here. Is there? Shouldn't there be a T in here? I think there should be a T in here. If I take a look at the paper, the next thing that happens is that control knot here that I do not understand. This seems to be, yeah, this is basically C0 being the ancilla qubit, but why? Okay, but U3 depends, so U3 is just a black box for them. But isn't there a T missing in here? Swap. So let me take, what's the swap decomposition? Composing swap, not swap, sorry. Hopefully gate decomposition. No, starts actually with an H. With an H with a Hadamard. Oh man, that's so bad. So it starts with a Hadamard. Then control knot. I guess it doesn't matter whether you do it this way or the other way around. Afterwards, there's a T dagger. That T here is weird. The T should really happen after the swap. That doesn't matter though. Yeah. Okay, because the swap here is to avoid exactly that. So as to basically, I think I might have missed the control knot then maybe, or something like that. What is in the paper? But in the paper it's like that. Because if I implement it this way, so what you want to avoid is that so what you want to avoid is the connection between Q0 and Q1, right? Because then it requires you to have a triangle. So that's why you're swapping. That's why they're swapping the cables. And then you get a TNH down below. I'm getting dizzy with this. Still kind of missing that extra control knot in here. I don't see it in here. Like I get the swap, but I think I'm still missing, because here they go, Hadamard, control X, T dagger, control X, T, control X, T dagger, and then there's another control X, but that's maybe let me implement it this way. So I would do control 1 to 2 control X. Now wait a second, why there is something's off here. Oh no, sorry, that's fine. Hadamard, then control X between 1 and 2, between 0 and 2, between 1 and 2, and then there's another one between 0 and 2. And then at that point, we are here. And now I still want to apply the T gates. Let me implement one without the swap first. Let's get rid of the swap. Let's get rid of everything that can bring problems. T on the qubit 1, TOF S, T on the qubit 2. Now there is TOF S, control X on qubit 0 and 1. TOF S, Hadamard on qubit 2. TOF S, T on qubit 0. T on qubit, T-dagger on qubit 1, sorry. And finally, a control X again between 0 and 1. And so we got this, and we got this. So now we got exactly that. Can this T be moved? T-dagger. Why there's no here? Rear. Okay. Then I get these, then I get the 2 T's, then I get, yeah, that should be about fine. That's exactly the way this looks like in here. And so if I now go ahead, and here I will ignore, I don't need to swap now. Just got these. Let's see what we get. Hopefully that works. Oh yes, baby, that works. That works even better. Okay, that works. Now, how can I add a swap in here? So that works. That's good. That's good. Now I will need to add the swap because I want to be able to implement that thing without having exactly that part in here. Because remember that so far we have connections between Q0 and Q1, between Q1 and Q2, and so we don't want to have now between Q1 and Q0, because that's gonna have that non-linear shape. And so we want to add a, so one way to deal with this would be that I would add, before this Hadamard here, let me say rear. Now let me, no, before the control X here. And now I can, after the barrier, I can swap. And now I basically need to change all the ones in here. So I'm going to swap between 1 and 2. So I need to change all the ones for 2s and all the 2s for 1s. So this is 2, this is 1, this is 2, this is 2. Now I should get these. And now we've got basically no connection between qubit 0 and qubit 1. Cool. That is about right. And now I basically, if I now add this swap here, right, because basically now my 1 and 2 are swapped, so I have to kind of correct that. I mean, I can do that like here at the end, right? I can just, so I don't have to add it there. So can I just do this now? And so 1 and 2 again. And so now basically I don't need to add it here, so I need to worry about this thing looking funny. So let's see, we're here. Oh good, oh good, oh good, oh good. Let's see. Yes, now works. So okay, so it seems like there is something off with this. It seems there's something off with these here. I got to figure out what, so I can report it to Rod, but that doesn't seem, this doesn't seem to work. This doesn't seem to work as I expect it to work. Let me quickly quirk. Okay, so I'm gonna finish the video here, right? But I just wanted to quickly test it out in Quirk and see, because now that's pretty cool. Those are neat results. That's definitely what I expected. It's of course a simulator, so now the next step would be get into an get it to run into actual hardware. That's where I wanted to go. But let me quickly. So that's an awkward diffusion construction, but it also doesn't seem to work. Let me see. Actually, I can try. I can easily try because I got it here. So does this work? Yeah, that works. Okay, makes sense. Okay, yeah, it kind of makes sense as I said, but I just wanted to make sure. So that works. I'm more used to the other constructions, so I'll just leave it this way. That works on the simulator. But I wanted to quickly check this thing here. So let me see. So we've got a Hadamard, we've got a control node, we've got a T-dagger, we've got another control node, a T-dagger, T. We've got another control node in here, and then we've got a T-1. Yeah. Then we've got a swap. Okay. Then we've got a swap. Right. And then we've got T and T. And we're going to do this way. And then we've got T-dagger up here. Hadamard, T, and PAM. And if, in theory, if we add another swap now, if we swap again, so let me just it's going to be easier for me to, if I use the actual swap. So I can easily I can then not get lost. So now this should behave like a Toffler gate, correct? if I do like a plus plus, yeah, and it doesn't. It definitely doesn't. That doesn't work. Doesn't behave like a Toffoli gate. There's a mistake in here. I think there's some operation missing. I think if I if I add another control X in here, I think that does this. That doesn't fix it either. No. That doesn't. So okay. So this is basically figure 10 doesn't seem to work. That's not a Toffoli. That's not how the Toffoli is supposed to. Okay, cool. I'll put that into the. So let me see. Can I export that as an image? Link JSON. No. Okay, but I got that in here, and so let me check a second. So I've got this little thing in here where I'm just collecting feedback for figure. So I think that will be heading 2, right? So heading to figure 10. So Toffoli, let's swap built-in circuit seems to be wrong, as it doesn't give the right output when C0 and C1 are in the plus state, for example. So here this is a link. So here's a link to Quirk, and I'm gonna put a screenshot as well. Oh, cool. Because so what would be missing in here would it be the it's missing. Okay, I know. This should be missing another control X here, I think. Yes, that works. Yes, that works. It's missing a control. Okay. Right after the last T dagger. It's missing a CX between C1 and T qubits right after the or right before the sub. Here, a working version. So that is a working version. That's correct, right? Only one, exactly. Those are invalid. So yeah. Here, a working version. Ah, oh, come on. Stupid bar. Here, a working version. Cool. So I got that chat already with him and with the team. So basically, that's cool. Yeah. Then I think that's it. We're ready for the next step, which is to basically get it into an actual machine. That's interesting. Nice.